Okay, so optimization again. So if 1,200 square centimeters of material is used to make a box with no lid and a square base, what dimensions will maximize the volume? Okay. So let's see what we're looking at. So we have a box with a square base and no lid. Okay, so we have X, and we have Y. So when talking about the surface area of this box, we have a base and we have 4 walls. So this 1,200 centimeters of material is going to equal a base plus 4 walls. All right? And so the question is, what dimensions maximize the volume? Well, the volume is going to equal x squared times y. And so we want y as a function of x. Okay, so we're going to manipulate our constraint to get to our, so that we can turn the volume into a function of one variable, then take its derivative, set it equals 0. All right. So y would equal, okay, so that would be 1,200 minus x squared, and now divided by 4x, okay? So 1,200 divided by 4 would just be 300 divided by x, and minus x divided by 4. Okay, so we've isolated y. We're going to take this y right here, that 300 divided by x minus x divided by 4, and we're going to plug it into this guy right here. So v is going to equal now x squared times 300 divided by x and minus x divided by 4, which would equal, all right, so x squared divided by x is just x. So it's 300x. All right, now x squared times x is going to be x cubed. It's minus x cubed divided by 4. Okay, great. So now we've got our volume as a function of one variable. So now we can take the derivative of this guy. So the derivative of the volume with respect to x is going to equal 300 now minus 3x squared, and then we're going to divide by 4. Oh, sorry, that other 0, I'm thinking about the next thing on the right, which equals 0. Okay, so taking the derivative of the volume with respect to x and just setting it equal to 0. Great. So negative 3x squared divided by 4 is going to equal negative 300. Okay, so I can multiply by 4 divided negative 4 over 3. Don't cancel it out on this side. So if I divide by 3, this is just going to turn into a 100. Okay, but if I multiply by 4, it's going to go 400. So x squared is going to equal 400. If I take the square root of both sides, I'm going to get that x is going to equal, now plus or minus 20. Only one of those makes any sense. X is going to equal 20. Okay? And so y is going to equal now 300 divided by 20, and then minus 20 divided by 4. Okay, so let's think about what this is. 300 divided by 20, just ignore those extra zeros. It's really 30 divided by 2. 30 divided by 2 is only going to be 15. Okay? And then 20 divided by 4 is going to be 5. So what does this thing come out to be? 15 minus 5. So 15 minus 5 would just equal 10. I believe we were doing this in centimeters, so let's get these guys quantities. 20 centimeters and 10 centimeters. Now, this didn't ask for what is the maximum volume. This just asks for what dimensions create the maximum volume.